Player movement is a fundamental mechanic for just about any game. And if you're completely new to game development, or new to Unity, or if you're just starting a new project, it's likely the first thing you want to do. Well, you came to the right place, since what you're seeing in the video is what we're going to create in this tutorial. So make sure to stick to the end where we put the finishing touches on the movement system. I've streamed this tutorial on my Twitch channel where I stream game development of my games and also tutorials such as this one. But I didn't use that footage in the video since I took my sweet time on stream. But make sure to check me out on Twitch, link is in the description below. Alright, so let's create a new Unity project. Click on New and then we're gonna select a 2D template. Name it any way you want. I'm gonna name mine Tutorial Series 1 and choose the location where you want it to be. Let's click Create and it's gonna take a minute. So the first order of business is to create an empty game object. I'll name it Player and make sure to tag it as Player. Now let's add the first component, a sprite renderer. This will display any image for our character or our game object. We currently don't have any, so I'll use a knob. But you're welcome to use my art. I left the link to this Google Drive folder where I've uploaded it. So that's the art I'm gonna be using. So let's go to the project folder and create a new folder. I'll name it Art. And now the sprites you've just downloaded, you can just simply drag and drop them into Unity. Now click on the art and we're gonna make a couple of settings. For sprite mode, select multiple and then 16 pixels per unit, filter mode to point no filter, and compression to none. Now hit apply. Let's click on the sprite editor. Let's slice it, select grid by cell size and enter 16 by 32. Yes. And apply. And now we have separate sprites for each pose of the player. Okay, so let's click on the player object again and click on the little knob. And now we have all of the sprites we've just imported. I'm just gonna use the first one to represent the player. Now let's add two more components to the player game object. The first one is going to be a box collider 2D that's gonna allow our character to interact with the world. And the second one is going to be a rigid body 2D. We can already head to the box collider, press on the edit collider, and we can shrink the collider down just like so. So it hugs his feet and it's a little more narrow than the body of the player. Now it's time to create some scripts. So let's go back to the asset folder and create a new folder. I name it scripts. And I usually like to add another folder just for player scripts. This really helps out down the road when the project gets bigger. Inside the player scripts folder, let's create a C# script. I'll name it player movement. So let's open up the script. As you can see, when you open the script, you already have two voids, a start void and an update void. The start one is executed only once and it's in the beginning when the object gets enabled. And the update method is being executed continuously. First, we need to create a variable. And we are going to make a private float and we'll name it speed. We'll adjust the speed while testing so we can get it right. And just above this variable we've just set, type serialized field, and this will make sure the float gets shown in the inspector even though it's private. We're gonna need to add two more variables. The first one is gonna be a vector3 and I'm gonna name it move direction. And the second one is going to be a private rigid body 2D and I'm gonna name it player rigid body. We're going to replace the start method with an awake method. An awake method is very similar to the start method, but it gets executed before the start method. So let's say private void awake. And inside it, we're gonna set the player rigid body. So we say player rigid body equals get component, and we want to get the rigid body to the component, and that's it. And now we have the rigid body in our script. Now to set the velocity of a rigid body, we're gonna use another new void, and it's called a fixed update. And the difference between a fixed update and a normal update is that a normal update gets executed once per frame, while the fixed update can get executed once or as many times as needed per frame. The fixed update is consistent, and we're gonna need it since we're doing player movement, and we don't want the player movement to vary based on our frames per second. So to set the velocity, let's say player rigid body dot velocity equals a new vector 3, and we're gonna use move direction, which we haven't set yet, and we're gonna say dot x times speed, and we're gonna use the y value as well, so move direction dot y times speed. So now we have to set the move direction variable, and in the move direction variable we want to capture the input of the player, and we can do that in the update void. So let's go to the update void, and the first thing we're gonna set is two floats. One will be called move x, and we're gonna set it as input.get axis raw, and the name is horizontal. And we're gonna do a very similar thing for the y-axis. We're gonna name the float move y, and the axis raw that we're gonna get is called vertical. You can change the settings, but by default it's set to WASD or the arrow keys on the keyboard, and it also works with a controller. I'm gonna show you how to change that in a minute. First, let's finish the script. Now that we have the inputs, let's set the move direction. So move direction equals a new vector 3, and we're gonna use the move x and move y variables we've just set, and for the z-axis we can set it to 0f, and we want to say dot normalized at the end to make sure the player speed doesn't vary if he's going diagonal or just in one direction. Okay, and that's it. So let's save the script, go back to Unity and let it compile. Now to change the input settings we talked about earlier, go to Edit, Project Settings, and Input Manager. We can see here the settings for horizontal and vertical axis. You can change them however you like if you don't like the default settings. Okay, let's go back, select our player, and we want to add the player movement script to our player. So simply drag and drop it to the inspector. Now you can set the speed to any value you'd like. I'll start with 3, and let's hit play so we can test and see how it feels. The player is moving pretty slowly. And also, if I'm not pressing any buttons, the player goes down. That's because we have a rigid body 2D applied, and there's a gravity scale of 1. So let's put that to 0 because we're gonna create a 4-way, or we have created a 4-way movement system, and it's usually used in a top-down style game, so you don't need to apply gravity that way. So I already know I want my player to move a bit faster. I'll set it to 4, and let's hit play to test it. And there we go, our player is moving. But you might have noticed we could only move in the space we've created. So if I, for example, well, let Unity compile, move above the camera, as you can see in the scene view, I'm still moving, but I can no longer see the player. So to change that, let's make a camera movement speed so the camera can follow the player. Let's go back to our assets folder and scripts, and I'm gonna create another folder. I'm gonna name it general game. And inside the folder, I'm gonna create a C# script and I'll name it camera movement. Okay, let's open the script. So first we're gonna want to set a variable. We want to know which game object are we following and see its transform, which holds the position of the game object. If we go back to Unity and select player and move him around, you can see in the top right corner that the values are changing as the player is moving. So let's go back to our script. We want to get the transform of the player. So let's make a private transform and I'll name it target. So once again, let's replace the start method with an awake method. So private void awake. So to set the target, we say target equals game object dot find game object with tag. And since we tagged our player as player, we have to say we're looking for a tag player, and then we want to get its transform, so dot transform. You don't want to be using find game object with tag too much, as if you have too many of those it will slow down the process, but I just wanted to show you another way you could get a game object into your script. And we are going to change the update method with the fixed update method for the same reasons we did in the player movement script. So let's say private void fixed update. And first we want to check if the camera position is different than the player position. So we say if transform.position, which is the camera position, does not equal target.position. And if that's true, that means we have to move the camera. So let's create a vector3. We'll name it target position. And we assign a new vector3 to it. For the x value, we use the target.position.x. And for the y value, we use the target.position.y. These are both x and y coordinates of the player. And for the z-axis, if we head back to Unity, you can see the player has a z value of 0, or the z-axis value, and the main camera has a z-axis value of -10. That's because in a 3D space we can see the camera is behind the player, so it can look at the player and project the world. So in our camera movement script, for the z-axis, we're gonna want to use the z position of the camera. So let's say transform.position.z. Okay, and now we want to set the position of the camera. So let's say transform.position equals vector3.lerp. And for the first vector3, we're gonna use the position of the camera, so transform.position. And for the second vector3, we're gonna use the target position variable we just set, so target position. And for the float, we can just enter 1.0f. Okay, so now let's save the script and head back to Unity. And now we want to apply the camera movement script to the main camera. And let's test it and see if it works. So the player should always stay in the middle of the camera now. And he does. Okay, let's stop the play mode. Right now the game is not really fun because we're just traveling through blue space. So to change that, let's go back to our art folder. And we're gonna use the second part of the art. And that's the tutorial overworld. Let's drag that into Unity. And we're gonna apply the same settings here. So sprite mode multiple, pixels per unity 16, filter mode to point no filter, and compression none. Now we go to the sprite editor and we're once again gonna slice it grid by cell size, but this time we're gonna slice it 16 by 16. Press slice and apply. Okay, and now we need to create a tile map. So in the hierarchy area, right click, select 2D object, tile map and rectangular. The first tile map, we're gonna name it ground. And we can duplicate it by pressing Ctrl+D. And I'm gonna rename it to collision. Okay, so with the collision tile map selected, let's add a component. And it's going to be a tile map collider 2D. And we can leave the settings as they were. Now we want to create a new tile palette. So let's click on the tile palette tab and create new palette. I'm gonna name mine tutorial overworld. Over here, I'm going to navigate to the assets folder and I'm gonna create a new folder. I'll name it tile maps and I'll save the tile palette in that folder. Now select the tutorial overworld and drag it onto the tile map. I'll save this in the same folder as before. Once Unity imports the art, we'll be able to use it. Okay, so make sure you have the ground layer selected and now you can paint any world you want. You can use the tools above, so select a sprite you would like to use and you can paint it. You can create any kind of game world you want. I'm just going to create a simple one and I'm going to fast forward this process. Okay, so once you're happy with the game world you've created, you're probably gonna notice the player is missing. Well, it's behind here. I can even show you. Let's delete a couple of these tile maps and we can see the player is hidden behind the world. So let's take a look. So the ground tile map has a tile map renderer and its sorting layer is set to default and order in layer set to 0. And the player also has a sprite renderer component that's also in the same sorting layer and in the same ordering layer. So let's change the player ordering layer to 1. And now he appears. So now you can go ahead and test your game world to see how it feels. The game is already looking more alive. However, there is still one major issue. If we go to the edge of the map, you can see the blue space and you don't want that. You don't want the players to see the out of bounds area. So we're gonna fix that. Let's go back to our camera movement script and we're gonna want to set two new variables. We're gonna have both of them be private, so a private vector2 because we're gonna only limit the x and y axis positions. So we're gonna need one for the maximum position, so I'll name it max position. And we're gonna need another one for the minimal position. So let's do the same thing, private vector2, but name it vector2, but name it min position. We're gonna want to see both of those in our inspector, so make sure to add serialize field in front of both of them. Okay, with these two variables, we are ready to make the camera stop at the edges, but we're gonna need to set them. So go to the fixed update and right after we set the target position, we are going to limit the target position x and y values by using the two variables we've just created. So let's say target position dot x equals math f dot clamp, and for the float value we're going to use target position dot x. And then for the float minimum, we're gonna use the min position dot x. And for the max float, we're gonna use the max position dot x. And we're gonna do the same thing, but for the y-axis. So you can copy this, and we'll change it to target position dot x, and another dot y, and another target position dot y, min position dot y, and max position dot y. Okay, so with that, we are ready to test it. Let's save the script and go back to Unity. Now click on the main camera, and we can see we now have max and min positions available in the inspector. With the movement tool selected, we can now pan the camera all the way up without showing the out of bounds area, and we can see the Y position is 5, and that's gonna be our max Y position. Then we move the camera down, and it's -5, and that's gonna be the minimal Y position. Let's do the same thing for the X-axis. If we go all the way to the right, that's going to be 7 as our max X position, or axis X position. And all the way to the left is -6, and that's going to be a minimal X position. Let's set the camera back to 0 on the X and Y axis, and let's test it. If everything works, our camera should no longer go in the out of bounds area. And we can see the camera stopped, and we can still move our player. However, our player is still just a static image. So let's change that and add some animations. Select the player game object, and we're gonna add an animator component. Now with our player object selected, go to the animations tab and click on create. We're gonna go to the assets folder and create another folder. I'll name it animations. And I'll set the file name to player movement. Now click save. Now we're gonna want to add player movement animations for all 4 directions. So in the animations tab, click over here and create new clip. We're already in the animations folder, and I'm gonna name mine player down as the first one. Click save. Now in the art folder, go to tutorial player walk 2, and you can preview your sprites in the bottom right corner. And we can see the first 4 sprites are for the player down movement. So we select all of them and drag them over to our animation timeline. And now you want to select the first frame, Ctrl C, and Ctrl V at the end to make sure we duplicate it. Now select all of them and drag them out, and I'm gonna set it to 45, and you can press the little play button here to preview the animation. Now if we haven't duplicated the last keyframe, let me show you. The animation would have a little stutter at the end. So that's why I suggest you duplicate the first frame as the last one. Now simply do the same thing for all 4 directions. I'm going to fast forward this part. Okay, now that you have completed all of the animations, let's continue. So I've just noticed that I messed up when doing the art and I don't have a left walk animations. But don't worry, I'll update that in the Google Drive so you'll have the correct left walk animation. Either way, let's continue. So with all the animations done, select the player and go to the Animator tab. We can now delete the 4 animations in the Animator tab since we're going to use a blend tree. Let's right click, select create state, and from new blend tree, I'm going to rename the blend tree to walking. And now we'll want to create 3 parameters for the animator. So let's click on the little plus button, and we're gonna first add 2 floats. The first one is gonna be called move X, and the second one is going to be named move Y. Now we're also gonna add a Boolean parameter. I'm gonna name it isMoving. Okay, so with parameters done, let's double click on walking and select the blend tree. As blend type, select 2D simple directional and select parameters move X and move Y. Now in the motion area, click on the little plus icon and select add motion fields. We're gonna need 4 motion fields. Now to each motion field, we're gonna put in an animation. So let's head to the animation folder. And let's move player down, player left, player right, and player up to our motion fields. And now we have to apply the position X and position Y. So for player down, it's gonna be position Y -1. For player left, the X is gonna be -1 and the Y 0. For player right, X is gonna be 1 and Y is gonna be 0. And for player up, position X is going to be 0 and position Y is going to be 1. Position X is going to be 0. Okay, it works. And now with motion fields done, we can go back to the base layer. And at this point, I suggest we create another animation for the player, the idle animation. So let's click on the player and create a new clip. I'm gonna name it player idle. And for the player idle animation, I'm just going to use the first sprite and it's going to loop. So it's gonna look like the player is standing still. Now we go back to the animator and we can delete the player movement orange box we have right now. And we can right click on player idle and set it as the default state. So now our character, whenever he starts animating, he's going to go into the player idle animation. And now we're gonna create 2 transitions. The first one from player idle to walking. And now you click on the arrow and we're gonna change some settings here. The first one, we're gonna uncheck the has exit time and the fixed duration, and we're gonna also set it to 0. And as a condition, we're gonna add a new one with a little plus button. And the condition is that our isMoving bool parameter is set to true. And now we need a transition from walking back to idle. So let's do that. Click on the transition. We'll also uncheck has exit time, fixed duration, and set it to 0. And the condition we're gonna set here is that the isMoving bool parameter is false. Okay, but for the animations to work properly, we're gonna have to adjust the player movement script. So let's open it up. Go to player movement. And we're going to need to reference the animator we just created. So let's create another variable, a private animator, and I'm gonna name mine player animator. Now let's go to the awake method and set the player animator component. Player animator equals get component, and the component we're searching for is the animator, and that's it. It's similar to what we did for the rigid body. Now let's head down to the update method, and we'll want to set the float parameters for the animator. So let's say player animator dot set float, and the first float we're gonna set is the move X, and we're gonna set it to move direction dot X value, and we'll do the same thing for the move Y parameter. So change it to Y and move Y. Make sure the name of the floats is exactly the same as the name of the parameters we've set over here. Okay, so with the float parameter set, we just need to set the bool parameter isMoving. So to do that, let's do a check. If move direction is not a vector 3.0, that means the player is moving. And if the player is moving, we'll set the player animator boolean value, so set bool. We named it isMoving. and we're gonna set it to true. Okay. And if the if condition statement comes back false, that means the player is not moving. So let's set player animator dot set bool. The bool we're setting is moving, and we're gonna set it to false. Okay, so let's save the script, head back to Unity. After it's done compiling, we can test it. So let's hit the play button. And we can see the player is now animated in the correct way, except for me when moving left. Now it's just a cool moonwalk backwards. So you can also do that if you prefer the moonwalk. But again, the art on the Google Drive is going to be updated, so you'll have the correct moving left animation. Okay, there's one last thing for us to do. If we switch over to the scene view and we move with our player to the left, we can see the player can also move outside of the map area. For that, we're gonna have to set colliders. If we take a look at the player, we can already see we have set a box collider 2D. And if you remember, on the collision tile map, we have also set a tile map collider. But so far we haven't used the collision tile map, so let's do that. Select grid, go to tile palette, make sure the active tile map is set to collision, and you can use these border sprites to set the edge of the map. So let's select one, and oh, we can't see it. It's because it's behind the ground layer. So let's select the collision layer and set its order in layer to 1. Make sure you also go to the player and set his order layer to 2, as we want the player visible above the collision layer. So now let's paint the edge of the map. Before we get to testing, select the player and in the rigid body, go under constraints and freeze rotation on the Z-axis. Now let's hit play and test it. Okay, great. As you can see, the player can no longer walk outside of the edge of the map, and he also collides correctly with the cluster of trees in the middle. If you've learned something in this video or just enjoyed watching it, consider liking the video and subscribing. If you like this format and you want to see more tutorials such as this one, let me know in the comment section. Thank you for watching, and I'll see you in the next one.